Hello everyone, my name is Lim Jong-hyun, the presenter of Team 2. The members of our team is Shin Ki-tae, Park Seung-jun, Cho Min-sung, Baek Ji-hong, and Lim Jong-hyun. This is our weekly plan. This week, we are going to study on double cone and crown. I will proceed with the contents as below. Last week, our team presented about double cone. A double cone serves to withstand the load of a big loop. Our team looked for answer to the professor's question in the last presentation. This is the data of facilities in big loop. You can see that there are bar and restaurants in big loop. This week, we will talk about the specific issue of double cone. First, I will talk about double cone. The largest top ring has a diameter of 33 meters, 10 meters away from the lower concrete structure. The lower concrete structure is the smallest and has a diameter of 18.4 meters. Due to the high moment load of the double cone, all the members form fixed moment connections to permit minimal rotational movement at the junction points. All of the generics and diagonal members, which is blue, red, purple, have a size of 400 meter multiply 300 millimeter. But the size of the ring section on the connecting joints, which is green, are slightly larger. Size is 429 mm multiply 300 mm. The reason of difference is the offset between the member axis in the connecting joint is not acceptable. So, the section size of the rings are slightly larger. Size is 429 mm multiply 300 mm. Next, I will talk about the lower parts of double cone. The lower part of the double cone is made up of concrete walls as shown in the picture. There are 14 shear walls that are connected by a single concrete ring beam. At the top of this, a bearing beam transfers the load to concrete. The concrete wall contains a large shear reinforcement bar, which allows the load to be transferred safely from the steel frame to the concrete. And it can prevent the structure from collapsing. This concrete wall is located on a foundation slab supported by a previously drilled column. And the height of the wall is 7.35 meters from the surface, and it continues to the basement. Next, I will talk about structure of the crown. In Busan Cinema Center, A structure is needed to support a cantilever roof, 85 in the front and 45 in the rear. Therefore, the structure of the double cone had to be designed to support the load of the cantilever roof. So, I think the most important part of the structural engineering perspective is the circular double cone point that connects directly to the cantilever on the roof. This upper part is called crown. The point where the roof of the octagonal structure meets double cone with circular structure is called the crown. The crown forms a structural transformation between a roof with an octagonal structure and a double cone with a circular structure. As you can see the picture, the crown may softly convert big moment pulses. Crown consists of two double links, which are connected by rigid vertical and horizontal members. Two rings are placed in one plane and have an offset of 5 meters. The inner ring of the upper ring plane is having a diameter of 40 meters. The inner ring of the lower ring plane is having a diameter of 33 meters. The depth of the crown structure, hence the vertical distance between the two ring planes, is 9.5 meters. It is divided into 32 segments with vertical and diagonal members connecting to doubling planes. Beams on the roof and members of the ring are joined through welding at the point where they intersect, and the girders on the roof are occasionally present. And I will explain the order of construction of the double cone structure. After the RC wall construction of the lower part is completed, the double cone is constructed sequentially. Install the system scaffolding and place the lower ring on it to connect it to the lower part of the double cone. Install the additionally system scaffolding and install the crown upper ring on it. Combine the crown upper and lower rings that transfer the moment power of the entire roof to the vertical material. Connect the upper part of the double cone. Finally, remove the system scaffolding and complete it. Thank you for listening. We are Team 2.